This video is the teacher material of Blockchain and Smart Contract class in National Chengchi University. Today, we will talk about one of the important underlying components of blockchain, hash function. First, let's talk about hash function. A function can map an input x to an output y. A hash function has some additional properties. It is a mapping function that can accept any form of digital data of arbitrary size and usually outputs a fixed length of the value. The output value is called hash value or just hash. Here is an oversimplified example of a hash function h1. Hash function equals h1 of x. X is the input and we assume x is an integer. x1 of h equals to x mod 100. The result of modulo operation is the remainder of x divided by 100. So if x is 52, then its hash value of h1 is 52 mod 100, which is 52. If x is 152, then its hash value is 52 as well. The definition of a fixed length of value means that the output is always between 0 to 99. And in this case, sometimes we write the hash value using 2 decimal digits, which is 00 to 99. So we call it a fixed length, which is 2 digits. Let's take a look at a real-world hash function, MD5. In the decimal system, you can only put 0 to 9 in a digit. And if you want to represent 10, you need one more digit and add 1 to the additional digit and put 0 in the original digit to make it 10, which is 10. Similarly, in the hexadecimal system, you can put 0 to 9 plus A to F in a digit. A is the 10th number that you can use in a digit, and F is the 15th number you can use in a digit. So if you want to represent 10, you don't need one more digit because you can use A to represent 10. So B is 11, C is 12, D is 13, E is 14, and F is 15. When it comes to 16, you already used all of the numbers in the hexadecimal system. So now you need one more digit, and 10 now represent 16 in the hexadecimal system. The hexadecimal system can help us to represent large numbers more easily, and it can be easily converted to a binary number more easily. Let's take a look at some example of the MD5 hash function. The input of MD5 can be any digital data, such as numbers, strings, or even a file. We can always find a way to transfer the digital data to a hexadecimal number as the input. The length of the output of MD5 is 32 digits using the hexadecimal system. For example, if you put A in MD5 hash function, and output will be 7FC56, etc. A real-world hash function has several properties. First, the function should be deterministic. It means given a specific input, the output is always the same. There has no random, undeterministic, time-dependent calculation in this function. You can find MD5's formula in Wikipedia. Note that there exist many different inputs that can output the same hash value, just like 52, 152, 252. All of them can output the same value of h1. In this case of different input with the same output, we call it hash collision. Second, the hash function is open to the public. Everyone can reproduce the result. Third, the hash function is invertible. That is, you can easily calculate the hash value from x, and it is nearly impossible to calculate x from the given hash value y in any mathematical approach. Theoretically, the only way to find the output to input mapping is through brute force attack. You can input all possible input to the hash function and save them in the database. The mapping table is called rainbow table. Once you want to do such reverse mapping, just look up the database and see if there is any output that matches your desired output. However, in modern hash function design, the length of the output is extremely long. As mentioned, the output length of MD5 is 128 bits. If you can find a 1-to-1 mapping of MD5's input to output, at least you need a very large entries to record all possible mappings. Fourth, the output of a series of input are approximately uniform. Let's make an observation of MD5 output. We use 0 to 100,000 as the input, and there are the hash values. We group the hash value by their first two hexadecimal digits. There will be a total of 256 groups, and there is a distribution of the groups. We can see that the number of output in each group is around 390. It means that the result of MD5 is evenly distributed in these 256 groups. We also show that the grouping result of using the last two hexadecimal digits. It still shows the result is quite even. It indicates that the MD5 function can evenly distribute input values to output values. Fifth, the next hash value is unpredictable. Here is the hash value of the character A and B. Even if you know A and its hash value, it is not possible to predict the next hash. Here's another example. If you change the input slightly, the output would be changed dramatically. We will not go over how a hash function is designed, but there are some well-known hash functions that you should know. So here's a table. There are several reasons that we need a hash function. One of the best known applications is to detect duplicated digital objects. For example, I have several large files containing any arbitrary digital data, such as numbers, articles, or digital images. I can calculate the hash value of each file and store them in the database. And by finding the same hash values, we can determine if there exist same input files, so that we do not need to compare those large files directly. Although we may have hash collision problems here, that is, different inputs may have the same hash values, but generally speaking, if the length of the output digit is larger, we can lower the possibility of hash collision. It is easy to understand that each one has only 2 digits, so that it has 100 buckets as the output. Any arbitrary input has the probability of 1% to enter one of the buckets. And modern SHA-256 has 2 power 256 buckets, and we consider that it is almost impossible to collide. So we can always use a hash function to identify the uniqueness of an arbitrary input. Such property can be used in some applications. For example, a hash function can be used to protect intellectual property. A writer can digitize his new novel and announce its hash value to the public without announcing its manuscript, which is the input of the hash function. The writer can claim that he or she wrote the novel before the date the hash value is announced. A hash value can be used as an authenticity. A programmer can release a program with its hash value so that you can check the hash value before installing it to make sure the program you download from the internet is genuine, not a fake or malicious software.